In this video, let us continue to solve problems based on probability. The question here reads like this. A die is thrown 1,000 times with the frequencies for the outcomes 1, 2, 3, 4, 5 and 6 is given in the frequency data below. So the outcome here is, of course, a die has got 6 numbers, 1, 2, 3, 4, 5 and 6. The frequency of each of them is given below, 179 for 1, 150 for 2, 157 for 3, 149 for 4, 175 for 5 and 190 for 6. Now find the probability of getting each outcome. Now this is no different from the problems that we've solved in the previous videos, except that we've got 6 events to account for here. So let us denote each event. That is, getting a 1 is one event, getting a 2 is another event, and so on. So let us write it like this. Event 1 is denoted by E1. Event 2 is denoted by E2. Event 3 is denoted by E3. Event 4 is denoted by E4, and event 5 denoted by E5. Event 6 denoted by E6. So now the probability of the outcome 1, that is nothing but P of E1. The probability of event E1 is nothing but the frequency of 1, right? The number of times 1 has come, that is the frequency of 1, by the total number of times, or the total number of trials is the usual way to say it. But in this problem, let's be a little more specific by saying the total number of times the die is thrown. So the frequency of 1 is 179 and the total number of times the die is thrown is 1,000. So we get the probability of the event 1 as 0.179. The probability of the outcome of 1 is a 0.179. So similarly, the probability of event 2, or the probability of the outcome of the 2 in a die, is nothing but 150 by 1,000, which is nothing but 0.150, which is the same as 0.15. So the probability of the event 2 is 0.15. The probability of event 3 is 157 by 1,000, which is nothing but 0.157. The probability of event 4 is 149 by 1,000, which is 0.149. And the probability of event 5 is 175 by 1,000, which is 0.175. And the probability of event 6, that is the probability of the outcome of the number 6 on the die, is 190 by 1,000, which is equal to 0.190, which is the maximum, so which is the most. Now also note that the sum of all the probabilities here, that is 0.179, 0.15 and so on, equals 1. And the sum of all the probabilities is 1. And yeah, the most important point is the probability of each event lies between 0 and 1. Either it happens, or it happens a number of times, or it happens every time. It does not happen more than the number of times the trial is done. That's what it means when we say that the event lies between 0 and 1. And E1, E2, E3, E4, E5, E6 all cover the possible outcomes of a trial. So let us solve another problem. Here we have another question. The record of a weather station shows that out of the past 250 consecutive days, its weather forecast were correct 175 times. So what is the probability that on a given day it was correct, and what is the probability that it was not correct on a given day? This is not a very complicated thing. This is quite a simple problem to solve. Now the total number of days given is 250, which is the most important thing. So that is nothing but that is the total number of trials. So now let us name the events. Now we have 2 events. One was correct and one was not correct. So let us name it like C is the correct and NC is not correct. So let us first find the probability that on a given day the weather forecast by the weather station was correct. That is P of C. That is the probability of the event C is nothing but the number of days when the forecast was correct. That is 175 by the total number of days for which the record is available. That is 250, which is nothing but 0.7. So the probability of the weather forecast being correct on a given day is a 0.7. Now, what is the probability of the weather forecast not being correct on a given day? That is nothing but, now we've got 175 times correct out of 250. So obviously not correct is 250 minus 175, which is nothing but 75. Subtract 175 from 250, we get 75. So the probability of the weather forecast not being correct on any given day is nothing but the total number of days when the forecast was not correct, which is 75 divided by 250. That is the total number of trials. So here we have 0.3. So therefore, the probability of the forecast not being correct on a given day is 0.3. Let me just write in the brackets for your reference. What is this? The forecast being correct by total trials. Here, the forecast not being correct divided by total trials again. So here we've got the answers for both the questions that are asked in this problem.